service director is Brian Biggs. He was one of our linemen. Les has been doing this doing line work for about 42 years, probably even more. Older than a lot of you guys. Yeah, except for Alan. Les is basically going to talk to you guys about the dangers of working around power lines. So some of it's going to be geared towards our linemen, some of it will be geared towards our first responders, and then our contractors. So if you guys have any questions, you can stop us during the presentation and ask. Just keep in mind that both these guys have to be very focused on what they're doing, okay? We're dealing with 7,200 volts up there.
Want to go cut us a tree, Barry?
It's not a good time.
Trees? Did you get a tree branch today? Well, I just got one.
Who's one?
Just grab one right here.
Oh, you, Les.
Okay, guys, like Alex says, our objective is to teach you a little bit about the electrical safety, because most of you are in the field of some way related to it. Like it or not, electricity is more of a thing today than it was when I started 40 years ago. Everything depends upon electricity. Pumps, lights, heating, cooling, everything we live with is driven by electricity. There are some inherent dangers to it, but we want to teach you that actually it's safe. You'll notice everybody says that if there's an accident, they say that it jumped out and got them. Electricity, it jumped. Well, we're going to show you electricity doesn't jump. Matter of fact, right here, that little plastic bell is 9 inches long. And according to the standards in the industry, you only need 1 inch per 1,000 volts. So we have 7,200 volts we're going to energize that at. It doesn't jump 9 inches. It lives that way all of its life within that 9-inch range. And that's at this elevation. At even 14,000 feet, it's good. As you get down to sea level, they call it VIL, that changes because of humidity and density of air. But electricity doesn't jump. It's safe. Contact is where the problem is. Our dummy here, he has every form of personal protective gear you can put on him. He's got rubber gloves on, he's got FR pants and FR shirt, hard hat, he's good to go. But we're going to talk a little bit just alignment. Is he really ready? Is his personal protective gear going to protect him? With trees, we find that many times people call in, they got a branch on the line. First responders, you guys get this all the time. The guy wants to go out and just take that branch off. That's bad. We're going to show you why, what's actually happening with that branch there. It's a red path to ground. One thing you want to remember about electricity, it always wants to get to its source. That's all, nothing more. It's trying to connect the circuit to get back to the generator. Because electricity is not on the outside of the wire, it's not inside the wire, it actually becomes the wire. Electricity works by a bumping of molecules. Let me take the first responder. Stand tight shoulder to shoulder if you would. This is how electricity works. 110 volts is a pump like this, and that pump just goes down the line of the molecules. 7,000 volts is a bigger bump. 115,000. And that's all it is. It's a bumping of molecules. So that's why you don't see anything, you don't hear anything. It's just the wire itself, the molecules moving across. We have to compensate by putting bigger wire up because of load, because of how much load is trying to go through them, how many molecules are trying to bump along after the generator. So that's all electricity is a movement of molecules. We take it off at the end through a transformer, we step it down to where we can use it in our house. So that's how lightning or electricity works there. And what we'll do is just control it and contain it. So in our demonstration, we're going to show how safe it really is. You're going to see an arc. The arc is actually plasma. The temperature of that arc is right near the temperature of the sun. So that's why the linemen have this protective gear on. First responders have their arc flash gear on that's calorie rated to protect you at that temperature. But it's only good for a period of time. So problem comes in is just lack of knowledge of electricity. You all work around it, so that's why we're just trying to give you a little bit of enhancement about what it does, how it works, how to protect ourselves from it. We'll go through some different cases of what's happened that's resulted in fatalities. So we have actually a 3-point system here to protect ourselves. We have visible open, we have a manual open, and we have a guy watching. So when we work on lines, we always have, if it's hot, we have 2 guys watching. We work everything with sticks that are dielectrically tested to withstand voltage for 100,000 kVA per inch. We're working with 8 foot, so we're good. It doesn't break down. There's questions come in. Some guys work with rubber gloves on, some guys don't. It just depends on what the manufacturer's recommendation is and what the company is. But we're wanting to teach you guys, if it's on the line, if the line's down, stay away from it. So that's the big thing we're trying to instruct everyone about today. When in doubt, guess it to be hot. There's no other way. And besides, you don't know on the line what wire is down. Is it a primary wire, the 7,000 volt? Is it the return that has really no voltage in it but does contain amperage? Is it a phone wire? Is it a secondary wire? So it's best just to call in those cases. Even with you guys working on the trees, the work could be done in the neutral, but if the bond is open, that could be the path to ground. So even removing the tree from the neutral, you could be the path to ground. So you have to be very cautious about that and how you work it there. You know, you guys got pretty stringent regulations of working trees in energized lines or near energized lines, and that's good. So we know what your safety practices are. We're just helping you appreciate that. Remember, how much electricity does it take to kill a person? How many amps? Lineman?
1/10 of an amp.
1/10 of an amp. Actually, when we short this out on the secondary side, we find we almost have 3,000 amps. You think that would kill you? Stops your heart in a heartbeat. Ha! Joke. Or even faster. So we're just going to give you some demonstrations. First, we'll show you a guy with all of the personal protective gear. This is more for the lineman. And we'll go through it and notice there's no problem here. Just heat them up. First, we're energizing the transformer. We've energized the transformer. It's back feed, so it's coming up our cable. Now, a transformer is looking, you can feed it either way. You feed it in 7,000, it comes out 120. You feed it in 120, it's going to come out 7,000. It's just a reverse.
Did you hear it? You heard it? You heard me click that, but did you hear the electricity go in the line?
No.
It's there.
Can't hear it, can't see it. So just assume it's always hot there. So we're going to test to make sure we're hot here, so we have an indicator that will tell us if the line's hot or not.
Repeat. Means the line's energized.
So we know that our line is hot. So anything up on that is now energized at 7,000 volts. We notice it's not jumping anywhere. Our little stick here, we're going to bridge across here just to show you that line is hot. That's a hot line. That's plasma. That's 7,000 volts. That's why they use plasma for cutting metal. They put air pressure to it, and you can cut through 10 inches of steel with a plasma cutter. So our lineman, let's see if he's okay. No problem. He's got all of his personal protective gear on. How about his rubber gloves if he's working on line? Yep, he's good. So our lineman is good. Once we're going to open it up there, Brian, we'll kick the hard hat off.
Let me check it in.
Now this is just the everyday guy. And it's happened, we've had guys that have put their heads up into wires in the bucket truck. We've had firemen that have been working in cities and somebody raised the bucket up into the primary line. Well, the problem is, with no protection on your head, and even if you're hard hat, you have a hard hat but it's not rated and it's not tested, it's actually the same as no hard hat. So let's go ahead and heat it back up there. We are hot. So now what happens if somebody comes in contact with the line with their head gets into it, if a lineman goes up and bumps into it? Okay. all that energy go? Right to the heart. Because like I said, it's trying to create a path to ground. So the natural thing is through the heart. All your blood goes through your heart. What's the body made up of? Water, sodium, tissue. Well, that's why we use the hot dog. It's the closest thing to a man we can find, because it's water, sodium, and pig, pork, and all men are pigs. So the other thing we find, the first responders find with electrical injuries, their back is most of the time broken. That's because of your spinal column. It already has an electrical pulse going through it, so that's a perfect track. So what happens? It constricts or break the back. So even if an individual is alive, a lot of times will have broken back, something you have to be aware of, because the constriction through that pulse of the body will break the back, breaks bones almost every time. So that's something you have to look for. So, once again, you notice it came out right at the heart. Anybody want a hot dog? Pretty well cooked. No. That's my grandson. Of course he would eat it. He'll eat anything. But see, notice that it didn't arc until I came in direct contact with it. As a matter of fact, even at 115,000 volts, that field is only just a few inches around it. It does create a field on the outside. Perhaps you've gone under really high voltage lines, the 230 or the 345 lines that are going across country, and you'll actually hear them, especially in the wintertime. If you're out hunting, guys, you'll notice that, you hear that. Those are free ions that are coming off there. And that's why you have to maintain that distance to ground, otherwise they just want to start drawing it off in this line loss. So you have to keep that distance to ground. If you want to have some real fun with your kids sometime in the winter when it's foggy and overcast, take just a fluorescent bulb, like a 4-foot fluorescent bulb out of your house, and just stand out underneath that and hold it up. The free ions will ignite that bulb. So you look like Darth Vader out there. So it will ignite it, enough free ions. But still, all of that energy is in that tight field. Here, it's within just a fraction of an inch on the outside. Maybe a 1/16 to a 1/4 of an inch you have to be within before it's going to bridge across.